Gaurav sir.
Yes, sir.
Yeah. Okay. Good morning to one and all present over here. Here we are coming with another webinar organized by Dr. Gaurav Verma in the topic monitoring and controlling through cloud using NodeMCU and IoT perspective. Before that, let me give you a brief introduction about Dr. Gaurav Verma. Dr. Gaurav Verma is currently working as an assistant professor, senior grade, and research head, IoT, AI, and embedded system at Department of Electronics and Communication Engineering, Jaypee Institute of Information Technology, deemed to be University, Noida, India, from July 2013 onwards. Prior to this, Dr. Verma has worked as an assistant professor and coordinator first year with Viseswarya Group of Institution, Dadri, Greater Noida from August 2012 to July 2013. He has also worked as a senior lecturer and MTech coordinator with Dehradun Institute of Technology, Dehradun from October 2008 to July 2010. From October 2007 to October 2008, he has worked as a senior lecturer with Dev Bhumi Institute of Technology, Dehradun, India. He has also worked as an assistant manager cum embedded trainer with Setpa Infotech Private Limited from October 2005 to September 2007. Dr. Gaurav Verma is an IEEE senior member and also the member of website and portal management subcommittee of IEEE UP section region 10. On behalf of Lord Buddha Education Foundation, Kathmandu, Nepal, I am hereby inviting you, Dr. Verma, to please share your knowledge so that we can get enlightened with your knowledge about the IoT and all. Thank you.
Uh, uh, Thank you so much, Mr. Jyotirman, for your kind introduction. And so, good morning to all of you, one and all. First of all, I would like to um, give thanks to Professor Dr. Kottish for providing me the opportunity to share my knowledge onto the particular topic, that is monitoring and controlling through cloud using NodeMCU and IoT perspective. Sir, is my voice is audible? Fine.
Yes, sir, it is audible.
Okay. And also to the LBEF and the Asian Pacific Institute members and the committees. So my heartiest thanks to all of them for such kind of organization of webinar. So dear, so I think all of them are students.
Yes,
We
sir.
have
Faculties are also there in the meeting.
faculties are also there. Okay. So dear all students and faculties. So today we are going to actually discuss about the IoT perspective. Okay, what is an IoT perspective? Basically, what I would basically like to cover in this particular webinar, I would like to give you the introduction to IoT. That is, what is an IoT basically? What is its definition? How can you understood the term IoT? Then we will discuss about the different IoT communication models, right? What are the different communication models that has been adopted for uh, for exchanging the information from one place to another place in IoT framework. Then what are the different components of an IoT framework or ecosystem? What are the different networking protocols that has been adopted for exchanging the information in IoT framework? What are the different hardware platforms available for IoT? What are the different cloud platforms available for IoT? Then After that, I will take one example if time permits to us. So definitely I would like to show some hands-on to you people. So for that, I will take one IoT board with the name NodeMCU, and then we'll see how can you, and one cloud platform that is ThinkSpeak, and then we will see how can we utilize this hardware platform and the cloud platform to formulate these two case studies. The two case studies are a simple case studies I have formulated just to for you people to understand the concept. One is called controlling of an IoT from a web interface, from a web page, and another is visualization of sensor data over the cloud, that is temperature and humidity sensor. So let's see how much time it will take to discuss up to this point, and then how much time would be left for this part. Okay, so accordingly, uh, we'll follow. So I will try to cover the things in half an hour from this point to this point, and then within the half an hour we'll try to cover this point. Okay, from here to here. And if during the discussion, if anybody feel any doubt or any of the thing, you voluntarily please may ask, right? So dear all, internet of things is a buzzword nowadays, and everywhere we can hear IoT um, is adopted in different sectors of the fields. Okay, and when we talk about internet of things, so it is very much understood that it is being it is somewhere using internet. Okay, the other part that is related to it, that is called things. So we have to understand how these two things, that two words, internet and things, are joined together so as to formulate the internet of things. Okay, so internet, you people know very well what is an internet. Basically, internet is nothing but it is the network of networks. Okay, and that may consist of private, public, academic, government, any local or global network, and with the help of, for exchanging the data from one point to another point with the help of some, either in the wireless mode or with the help of some optical networking technologies. Okay, and we know that for transferring or for exchanging the data, the internet use TCP/IP protocol. So in IoT framework or in IoT scenario, what we are going to do, we are going to utilize this internet only that we are using from the last 15 to 20 years. We are actually going to use this concept only itself of internet. Nothing has been new about the internet in IoT. It is not like that the internet would be something different in IoT case. We are going to utilize the existing resources of internet, what we are having, for the case of IoT also. So this is what we referred as an internet in IoT. So that is clear that we are going to use the existing resource. Next is thing. What is thing inside this internet of things? So thing is nothing but in IoT sense, it is refers to an embedded system or an embedded device, basically, right? So you people know that before the population, before the concept of IoT, okay, before its popularity, so embedded systems are there. Okay, they are still basically, but now they are become the part of an bigger picture, that is IoT. But however, still embedded devices are made for different forms of applications. So in IoT, these things are nothing but these are the embedded devices, which are embedded devices are nothing, or embedded systems are nothing. These are again the electronic systems, basically powered by using sensors, actuators, and having some communication interface. Okay, definitely a controller, so that it will control all these things. So when all these things are joined together and they are going to perform a specific task for some purpose, okay, for a specific work, then we can say that is an embedded device. Okay, there are lots of example of embedded device and systems. Okay, we'll take the example of your simple calculator. It is an embedded system, embedded device. We'll take the example of your remote. It is also an embedded device. Okay, remote of your TV, whether it is a remote of your AC. Nowadays, it has been seen that in a normal US house or Indian house, we can say that we are equipped with around 20 to 40 embedded devices, and we are not actually aware of it in some in some form and in some another. So we are there and we are actually using, but user actually doesn't aware that they are going to use embedded. So there is a huge market of embedded systems. You can understand. In India, there is a 135 crore population, and almost half of them are privileged, and every house will count that there would be a 20 to 25 embedded devices. So you can understand what is where is the market and what is the market, right? So what IoT IoT says that presently a human being is using these devices to communicate with another device, either with using some sort of short protocols or short communication effects or short communication protocols like your Bluetooth or your RF or something like that, or IR. Okay, but what IoT says that we want to we want these devices to communicate in any part of the world from each other without or with the need of human intervention. So this is basically the concept behind the IoT. The researchers want the devices to communicate with each other, to exchange the data at a very long distance, where one device is at say one place, somewhere in Nepal or somewhere in India, or say and another maybe in some Australia or in some US or somewhere else. And they may communicate each other. They may exchange the data with the help of human intervention or without the help of human. Okay, this is the broader aspect. However, what they want the devices to make self-intelligent or so much intelligent that they may communicate, they may adopt in our environment in such a way that human life becomes more easy. The main goal of IoT is to make the human life more easier. That is the main goal, basically. For an example, suppose if you have a fridge and in your fridge will make that fridge is so much intelligent and will make the IoT capability in that if and any sort of time that your fridge remember all the stocks in it, okay, it will check it out on daily basis what are the quantities that are left. Okay, then it may order itself from the nearby grocery store, and from there the some in grocery store also there is some IoT phenomena. Some robot is there or some drone is there. Okay, it will the uh, the man over there will put that particular product over it, and then it will delivered at your house and you may put it inside your fridge. Okay, so we'll try to automate the human life. We'll try to make the simpler human life. Okay, so that human intervention will become much lesser. Okay, so this is the main goal of IoT. So together both these, that's why the term is there, Internet of Things, and it is a broader term. Apart from that, there are nowadays lots of other terms has been populated or given by different researchers. Okay, as per the application of IoT. Suppose you are working in health sector domain and using the IoT technology, so that will become the IoT health sector, IOST. Similarly, if you are using in industry, then it will become the industry 4.0. Similarly, if you are using in wearables, so wearable of things. So similarly, lots of definitions and lots of further applications of this IoT will has been populated, and they are the, you can say they are now become the part of different definitions. Okay, but as a student or as a simple academician, what we can refer that if somebody asks us what is Internet of Things, so that we should have a proper definition in one or two line. What is it? So we can say that the Internet of Things is the network of physical objects and things embedded with electronics, software, sensors, and network connectivity, which enables these objects to collect and exchange the data in simple terms. Okay, so we can refer this definition and um, explain it better. But now you understand. I hope you are able to understand that what I mean to say about from this definition. What is the meaning of this definition? Okay, you may wonder to know that uh, when we talk about this internet and things. So previously, as I told you, that peoples were using the embedded devices. So and very few devices are connected to the internet. Okay, so IoT is not a new thing. It is also there from somewhere. It was started. Its concept was started somewhere after 2000 itself, but at that time it was not so much popular. And because you can understand at the time the internet technology was not so much you can say at the high level. So because 2G we were working on 2G or something, and then it was a phase of 3D transition. But now as 4G comes into picture, and now we are moving from 4G to 5G, now internet becomes so much proficient, and you can say important part of our life, that this IoT has been become so much popular after that. Okay, so somewhere in around 2003, we can see that the peoples on the earth are much more as compared to the things that are connected to the internet. So blue dot refers to the things that are connected to the internet, and then this brown color refers to the things number of peoples on the earth. Now, as you can say, the years has been progress and the development has been done. You can see that now we are in the era of 2020 and 2021, and we are now you see the effects of this. Now you can see that there are more number of things are connected on the earth as compared to the people. There will be 50 billion devices are there presently, okay, which are now being connected with the IoT. And definitely, it was an old data. Definitely, we are now moving towards much more towards that. Okay, IoT has applications in every sort of sectors, as I told you. These are these top 10 applications that I have downloaded from the internet and put it in front of you in a one slide. Now, if you will type it, the 10 most applications, you can find out that IoT nowadays find applications in every sector, whether it is a smart home, wearables, smart city, smart grid, industrial internet, connected car, connected health, retail, supply chain management, and so on. Okay, it hardly matters how much percentage it is having, but it has application in different sectors. Okay, so whether you are a civil engineer, whether you are a computer engineer, whether you are in health domain, whether you are working in electronics, computers, or any field, mechanical engineer, it hardly matters. You should know about it. Okay, because it has application everywhere, and somewhere somehow you will going to encounter. Okay, now the companies, these are the list of top 15 companies basically which are working in the domain of IoT. And again, you can see, you can visualize that it hardly matters that it is a semiconductor company, software company, networking company, hardware company, or it is a consumer product company, industrial equipment company. It hardly matters. All of them are nowadays want to make their systems or things smart. Okay, and that's why they are adopting this IoT, okay, in their products or in their system. So after learning this concept of IoT, we have open market basically, because IoT is not specific to any stream. It is basically, it comprises different streams of people. We'll see in IoT framework, then you will understand what I'm trying to say. It have the role. It requires the role of a networking engineer also. It requires the role of a software engineer also. It requires the role of an embedded engineer also. It requires the role of a computer science engineer, front end and back end developer also, and app developer also. Everywhere. So it is having lots of, well, it is a broad term, umbrella term basically, which which requires lots of things under it, so as to so as to complete the framework. Okay, right? Now, let us jump on towards the IoT communication models. What are the means? Once we have IoT, we understand. Okay, now we have to communicate, and yes, we there are the devices that are going to be communicated. They are the devices who are going to exchange the data. So, what are the different ways, or you can say the different path through which these devices can communicate with each other? Okay, so the simplest one, there are the different communication models have been proposed in the literature. There are the different communication models have been proposed in the literature, and that deals with the that will provide an insight that in how many ways you can communicate, you can build up the communication system over the IoT in between the or among the devices. So one model is device to device communication. It is sometimes also referred as machine to machine communication. Okay, what is in it inside? This model requires at least two devices. Okay, at least two device involvement of two devices. Okay, for the communication. And you may be wonder to know that it is not necessary that these two devices should have the involvement of internet. Yeah, it is. This is one of the IoT communication model, because you may be wondering that if it is not internet, how it can be qualified as an IoT model. Yes, it is, because when I will tell you about the IoT ecosystem, then you would understand that this type of communication in between the devices is also the part of a big picture IoT ecosystem. For an example, suppose you have a watch, okay, health band in your hand, okay, and you have a mobile. So your health band is somehow communicating with your mobile, okay, with the help of some sort of communication protocol, like it may be Bluetooth, or it may be Zigbee, or something else, okay, and it is sending the data of your health onto the mobile on some application. Now from that data, you want to share this data with the doctor, which is present at the hospital present. Okay, your important vital parameters of your body, you want to send this data presently to the doctor itself. So what you will do, you will share this data with the help of the mobile, with via internet, to to the doctor. Okay, because doctor is at maybe distant place, it may be in America, or it may be in some, maybe in some different, in some remote place. Okay, some distant place, and where normal protocols would not work, you need an internet to share the data. So your mobile phone is equipped with internet facility. It is having that module which is inside it is a Wi-Fi capability, and with the help of that capability, you can transfer the data to the doctor, to his mobile, or some sort, or his computer, which is also having some internet capability over there. So where this model fit in that particular complete communication, this model fits when you are transferring the data from health band to the mobile, where actually internet is not involved, but this particular model is a part of a big picture. Okay, so I hope you have understood this concept. Next communication model. Now, as I told you, it may involve Bluetooth engineering, Zigbee, Z-Wave, RF, etc. Now, another communication model that we have is called as the device to cloud communication model. Now, what is in it inside basically? In the case of device to cloud communication model, in the case of a device to cloud communication model, we have the device, okay, and this device directly uses the some Ethernet or Wi-Fi. As I told you, suppose you have your mobile, and this mobile is directly equipped with your with the Wi-Fi module or by Ethernet module. Okay, Wi-Fi and Ethernet module, you may understand. Wi-Fi is for basically for transferring the data with the wirelessly, and Ethernet is basically for transferring the data with the help of wired connection. So wired or wireless connection you have. So in the mobile you have a Wi-Fi for an example, and your mobile is sending the data to some cloud. Cloud means it is nothing but it is some server, okay, some sort of a storage area where you can send the data. So this is one of the model. Okay, Generally, students are using this model in their projects. Okay, and because for sending their device data, and in that case the device is one of the IoT board which is equipped with this type of Wi-Fi and Ethernet communication interface, and with the help of this they can easily transfer their data onto the cloud and represent the IoT product. Okay, so we'll see that model if time permits to us in this lecture. But there is some basically problem with this model. It is okay with the student's perspective, okay, or some sort of low level development. But when we talk about uh, high level development or some type of product development, then in that particular case there is an issue of interoperability occurs. Now what is that particular issue? Let us understand it. Suppose, for an example, you can see this is the basically uh, another communication model which is actually solving the problem of this interoperability. So with the help of this diagram, I will explain you what is the problem of interoperability and how this model is solving the problem. Okay. So in this particular diagram, you can visualize that we have three devices. And now suppose these three devices are not having that Wi-Fi or Ethernet capability directly. Now these devices may have either Bluetooth, Zigbee, Z-Wave, or RF type of communication interface. Okay, so what is the problem in that case? Because these are not equipped with Wi-Fi or Ethernet directly, so we cannot connect them to transfer the data over the cloud directly. So we need some Wi-Fi or Ethernet in there. So either we should need a mobile in between it. This type I have taken the example. So we'll send the data to mobile and then we'll send the data to cloud. But you can say the mobile is also having a limited set of protocol. It will either work with directly with Bluetooth or maybe some in some cases in case of RF. But what if we have different types of devices having different set of protocols controlling different types of things in your house or somewhere else in the warehouse or somewhere in the industry? So what is the solution to it? The solution to it is we should have a device, such type of device in between the cloud and these devices. We should have one more interface device which understand the protocol, these protocols, okay, and also understand the Wi-Fi. Means this device should have the um, capability to connect different protocol devices and also have the capability to connect with the Wi-Fi. Okay, so I hope you understand the issue of interoperability. In this case, the issue of interoperability means that when we have multiple devices of having different set of protocols, this model will generally not work. So this is what is the interoperability issue. Okay, because different manufacturers have different set of protocols. Okay, because you buy some one device to another manufacturer, buy another device from another manufacturer, like that. So there is an issue of interoperability. So what is this device basically which can solve this problem? This device is nothing but this device is called as a gateway. So this is what we call as a gateway, and with the help of this gateway we can transfer the information from these devices to the cloud, and we can interface at the input side different protocols devices which you can buy from different manufacturers. Okay, so in that case the monopoly of the manufacturer also not work. So you are providing the solution to it, because if you are using that model only, then there would be a monopoly of the manufacturer. You have to buy all the set of devices from the same manufacturer, and in that case inflation would be one. Okay, so inflation occurs. So in that particular case where monopoly, we have to reduce the monopoly of the manufacturer also. So we would buy one device from another manufacturer, another buy a device from another, where we find it is low cost device. But the problem is that they may have different set of protocol. So the solution to this is the gateway. Okay, so this is what we have, a gateway. And so this gateway is basically providing you basically a bridge between the different types of communication technologies. And it also help in, apart from this part, apart from bridging, it also helps in providing filtering and security implementation. Okay, So this software capability, that is filtering and security application, this software capability of this gateway, sometime also referred as edge computing. Nowadays it is also a very important word. It is referred as edge computing. Okay, so this filtering and security and all this part is referred as edge computing in this. So this model is a more generalized model, okay, where we have gateway and multiple devices can be deployed in any of the home or any of the organization perfectly. Okay, last model is basically the extension of this model itself. Okay, extension of this model itself. Okay, this is what we referred as a backend data sharing model. Sometimes when we transfer the data over to the cloud, okay, that we want that data, uh, because when we are sending the data to the cloud, what is the purpose basically? There should be some purpose for sending the data onto the cloud. The purpose is basically to have to get some or to extract some meaningful information from that data. Okay, so the cloud platform that we are going to use should have the capabilities so that it would extract some meaningful information of the data, so that it would be used further for increasing the growth of the organization. Okay, to get some pattern out of it, so that that pattern would be utilized by some of the companies, so to enhance their sale, to increase their business growth. So this is where they are more interested to send the data over the cloud from the IoT devices. Okay, definitely one of the purposes is monitoring, to monitor something, but the more advanced purpose is to analyze, and that cloud should have the capability. So we have different sort of clouds actually with different capabilities. Some clouds are very simple, where we can utilize them for monitoring purpose only. Okay, but in some sort of clouds, where commercial clouds, where we require some analytics and some analysis also, so where we have to send send the data to further advanced clouds also for that particular purpose. So this model is referred as backend data sharing model, in which is if one cloud is requesting the resources or sharing the resource its data to some other cloud for some purpose. Okay, so this is where this backend data sharing model comes into picture, right? So this cloud outsources data into different clouds for performing different types of operation like analytics and machine learning types of. So I have to get some insight of the data. Okay, so how can we conclude basically? So this is more of a generalized understanding to understand what is an IoT ecosystem basically. So in an IoT ecosystem, what we require. Okay, this is a more generalized model which is referring this model only. Okay, this is the generalized model. So this is another view of it. Okay, this one is the another view of it. So one thing, one point, this is what we call as a device level, and this is what we refer as a network level. Okay, so this is how. So you can see this is where we have the sensors and actuators and communication. This is what we word refer as a thing. So this is how it is going to be visualized. You can just, it is an example purpose. You have a device, okay, some sort of IoT board or some device you have, which is having some communication interface, some sensors and actuators are connected to it. Okay, okay, and not there may be a case there is not a single device, there may be a multiple devices also. Okay, suppose you have some agricultural field, and in that agricultural field you want to deploy some small nodes. Okay, nodes means these things. Okay, if a particular thing equipped with sensors, actuators and communication interface, sometimes also referred as a node. Okay, suppose you want to monitor the health of the soil from that actual agricultural field, so you have to deploy multiple nodes, this type of things into that particular execute field. Okay, so how these nodes are, all these nodes are basically going to interact with the gateway. So first of all, these nodes also have some networking phenomena. Either they should be connected in a mesh topology, or they should be connected in point-to-point topology. There should be some sort of communication networking topology over here. Okay, so this is what we call as a networking. Then it where they are connected with the gateway, as I told you. From the gateway, we can directly send them on the information onto the internet, and from the internet these are sent to the servers, where we have a cloud or some sort of terminal where we have servers for storing the data, and further analyzing the data. So this slide is providing you the more generalized and complete picture of an IoT system, that what are the components that are available in an IoT framework. We need a thing, we may need a gateway, okay, and we may require cloud, and the network and internet are the back end part of these things, okay, which may require. So these are the front end things that you may see as a hardware, and these are the backbone in the behind where we have these things deployed. Okay, so this is how this complete ecosystem is working, right? So uh, when we are talking that when these sensors are sending the data onto the gateway or onto the server, so in that case, what is there basically? We need some sort of protocol, okay, right? So before further extending my lecture, let me see. Oh, we already have 11:44. Okay, we have started at 11:20. I hope so. So, do you find any problem? Anybody of you, please let me know for the same. If you have any doubt, because anybody, if you want to say something till now or would like to ask something, anybody, please. Anybody who is listening, please tell me.
No, sir, there is no as of now. Once we get anything to ask, so surely we ask, sir.
Okay, okay.
Dr. Gaurav, your mic is mute.
Okay, sir. Thank you.
Yeah.
So yes, when we are saying that we need to work on the internet and we need to send the data via internet, so we never ignore the networking aspect of this internet. Okay, because definitely since last 20 to 25 years we are working on the internet, and we have some sort of system. Okay, so we have some networking standards and technology that we are using. Okay, so we are very much aware about this OSI model, that is your uh, a model which having different sort of layers, okay, for exchange, for sending the data from one point to the another point via internet: physical, data link, network, transport, session, presentation, application. And further you can see that this OSI model is grouped into TCP IP specifically for internet purpose, okay, which is can be further divided into physical, network, transport, and application layer. Okay, so every layer is very important, and in IoT system we came across every layer. Okay, and there is an opportunity for the designer to work at different layers, okay, to adopt or to take the advantage of every layer as per the application of their IoT system design. Okay, so what are the things that we required? At every layer we have some sort of basically protocols. Okay, let me talk about the protocols at the device layer, where we network in physical layer. So we have these protocols: Wi-Fi, IEEE, Ethernet, for for exchanging the information at the device side. Similarly, at internet layer we have IPv6. Nowadays, two new protocols have been added at this layer: 6LoWPAN and RPL, which is specifically for IoT applications. So similarly, at transport layer, we have UDP and TCP for connection-oriented and connection-less services. And application layer, we have HTTP. We are very much aware about this HTTP. Nowadays, at IoT, for specifically for IoT purpose, some new protocols have been added, like MQTT, AMQP, CUAPP, and XM. Okay, so whenever we are going to design an IoT system, we are using Definitely we are going to use some of the protocols, and sometimes we are unaware about it. And the choice of a particular protocol depends upon your application, right? Because in IoT, what we require sometimes we require low powered devices. Let me give you the example. These are some of the networking consideration and challenges that we have to keep in mind while designing our IoT system. That are the range, bandwidth, power uses, intermittent connectivity, interoperability, and security. Okay, range means what is when you are to transfer the data. So what is the distance? Bandwidth means what is the frequency range? Power usage, how much power is going to be utilized by the for sending the data. Internet connectivity means what is the um, same bandwidth, basically whether you are able to provide the intermittent connectivity or not. Internet connectivity means continuous connectivity or not. Interoperability I already discussed, and obviously the issue of security. So whenever we come across these points, for designing them, so we have to come across these points, and these protocols will help us to overcome or to manage these considerations or these challenges. So the researchers have designed these protocols in such a manner that they will provide low power usage, high bandwidth, okay, long range communication, then intermittent connectivity, interoperability, and as well as security also. Okay, so we may consider these protocols as per our application, as I told you, while designing the IoT system. Next, we can just focus on some of the popular hardware platforms, hardware and software platform basically. So when we talk as a student level, we are very fond of that. Okay, we want to design our first IoT application. So what we want that, okay, what sort of hardware we require, what sort of hardware we choose, and what sort of board we use. So what I have done, I have put some sort of popular boards for you in this particular slide, so that you can understand, okay, which board is utilized for which purpose. So I'm not going to discuss all these boards, rather than I will focus on one or two boards. Okay, so one of the popular board nowadays is the Raspberry Pi specifically. So now this Raspberry Pi is this board is basically a complete IoT board, and you can see this is a complete full CPU in a pocket size shape. Okay, you can see that it is having Ethernet interface, then you have USB interface over here, audio connectivity, HDMI cable connectivity. It is having their own GPU. You can put SD card and lots of other features provided with the 900 megahertz oscillate your frequency, and with the advanced ARM7 ARM Cortex CPU. Okay, so this board is basically more powerful board and more useful in the case of having where we require actually to execute complex systems, where we want to realize complex systems basically. Complex systems where we are which are computational intensive, like your image processing and signal processing or audio processing applications. So this board is more useful in that particular context because its cost is little bit high. That is somewhere around 3,500 to 5,000. Okay, in Indian rupees, right? So this board is preferred over where we actually have computational intensive applications. Okay, it is costly but powerful board, right? Apart from that, we have some low cost board also. Just like your Arduino, the students are very much familiar about this board because they utilize nowadays. Even 8th and 10th class students, even 6th and 7th class students are using this board as a plug and play device because it is very much popular open source platform. Okay, where we can realize our small systems within a fraction of seconds, within a fraction of hours basically. Okay, so what is it basically? This is a small size board which is having a onboard Atmega 3028 microcontroller, and you can connect it is having GPIO pins over here. Okay, and you can connect sensors and actuator with this particular board so as to realize your small embedded systems. But definitely It is because it is having 8-bit microcontroller only and having a limited frequency range around 4 to 16 megahertz, right? And limited processing capability, not like that, okay, which is the 32-bit microprocessor architecture over here. So this board is utilized for small applications, for low-level applications, for student applications where we require. Okay. Uh, Solely it is not qualified as an IoT board. What we require some even more interface chip with it so as to provide its Wi-Fi enabled capability. So when we interface this chip, which is an ESP8266 chip, which is nothing but which is a Wi-Fi chip basically. Okay. So if you want to realize any application with this Arduino board, what we need to connect this chip first of all, interface this chip with this, and then only we can realize an IoT application. Suppose you want to send some data onto the cloud, so this chip is required to be interfaced this microcontroller with this Arduino board. Both these cost somewhere around this would cost somewhere around 300 to 400, and this would also cost somewhere around in the same range of 200. Presently, there is a combination of these two things are coming into the market, are available in the market, that is referred as NodeMcU board. Okay. Now, what is this NodeMcU board? This NodeMcU board is nothing but it is, you can say that it is a combination of Arduino and ESP8266 on a single small size board. Okay. Right. Where we have a GPIO pins, right? Just like the Arduino, and we also have a equipped with ESP8266 Wi-Fi module, so as to directly realize the IoT applications. Okay, so where we want to design a small set of applications at the student level, so this board is very much prepared. Or where we want to design some compact systems. Okay, so this board is very much useful nowadays, right? So this is about the hardware platforms. Some other are also there, definitely having their own advantages and disadvantages. Then we have a cloud platforms, as I told you in my previous slides also, that clouds are very much important because IoT devices are generating the data, and that data need to be stored, because in your IoT device very limited memory is there, very limited RAM and ROM is there, and you cannot store that much of data. Okay, because you may require the data of 1 day, 2 day, even for a year, so for the analysis purpose. So your device cannot hold that data. So in that sense, you require the data to be uploaded on a large storage, okay, globally, so that it can be shared with everybody, to different peoples across the globe working in one or two organizations. So for that, clouds are utilized, and that clouds are providing the capabilities to analyze for the analysis of this data. So there are some commercial clouds available like IBM Watson, Amazon Web Services, Microsoft Azure. These are some of the commercial clouds that are available where you can utilize these clouds for the commercial applications. However, there are some open source clouds as well, where students can utilize for building their application for understanding purpose, like ThinkSpeak and Firebase and Google and so on. Okay, so there are some other open clouds are also available, which are free, and students can utilize for their applications, for building their applications, for building their products. Right. So this is what I have told you that I try to cover and wrap up in this format. Next, we have a hands-on part. So would you people would like me to cover first further also, or just I will discuss the applications, because time is more important. So is it possible to have half an more hour to discuss the things, or I should have to wrap up within a 5 minutes? Please let me know. Mr. Jyotirmay is there?
Yes. Hello.
Yes, sir. Yes, sir. But I'm saying that, or it is 11:58. So do we have more half an hour to demonstrate some hands-on to the students, or should I complete it with just only discuss the application and complete in 5 minutes? What do you suggest, sir?
Uh, It will be better if you can continue with the theoretical aspect rather than hands-on. It will be taking some time, I guess. Then,
Yes, 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 yes. Okay, okay, sir.
so
Okay,
it will
I
be okay if you can
no, no,
do
no.
this thing.
Yes, yes, I would do. No issue.
Yeah, okay, thank you.
And for that we may have some another session specifically for hands-on if
Yeah,
students are interested.
definitely, definitely,
Right,
definitely.
sir? Okay.
Yeah.
Hmm. Okay. So dear students and my and dear all faculties as well. So let me theoretically explain you the things because there is a paucity of time. So this is the NodeMCU board as I told you. Okay, right? Now how can we utilize this NodeMCU board? This NodeMCU board is these are some of the specification of these NodeMCU board, and these are the some of the specifications where we can have this can operate on 3.3 volt. It is having operating frequency better than your Arduino, that is 80 to 160 megahertz. Then RAM is there of sufficient 17 GPIO pins, one analog to digital converter as well of 10-bit resolution. Okay, and it supports your Wi-Fi and all these things, so there is no issue. And having low power consumption, low current consumption also, which leads to low power consumption, right? So this board is very much good board, specifically for development purpose, low level development purpose. These are this is the pin configuration. So let us skip this. Now, which tool you would utilize for the purpose of developing this? So for that, you can utilize this Arduino IDE software. Okay, the same Arduino IDE software you can utilize. Okay, you can install it from here, from this link, and its interface look like that. Is the interface. Okay, and uh, these are the steps. How can you actually write the program and link in that? So we'll have this session somewhere in another session for that. Okay, so yeah, this is the thing, is speak cloud. Okay, that we can utilize. So this cloud is basically an open source cloud provided by the uh, MATLAB company. Okay, it is basically the initiative of MATLAB company itself. Okay, MathWorks basically. Okay, not MATLAB company. It is a initiative of MathWorks company. This thing is speak cloud, where you can utilize basically which can you utilize for sending the information onto the cloud. So it is a very much good platform. We'll see in some another lecture how can we utilize this platform for sending and receiving the information. Definitely. Okay, and how can we configure this platform for visualizing the data? Okay. Now, yes, these are the two applications that you may people may build. Okay, controlling an actuator connected to. So basically, IoT is all about monitoring and control. Okay, either you are sending the data onto the cloud. Okay, this is one scenario. Means you have some sensor attached to the device, and that sensor is sending the data onto the cloud, some temperature or humidity sensor. And similarly, another, this is called one, this is what we call as visualization or monitoring. Second, we have we can say that we have uh, some actuator, some actuator is connected with your NodeMCU board, and remotely you are controlling that actuator from with the help of some web interface or some web page. Okay, suppose you are sitting somewhere in Nepal and I'm having some device over here. So with the help of that web page, you can able to control this device, my device sitting, which is at my place. Okay, so these type of two type of applications are generally utilized, and these are the two things generally it is done, that is called monitoring and control. Okay, so what type of control application you can design or we can discuss later on. Let's discuss over here. Okay, suppose you have a NodeMCU board and you have connected one LED over it. Okay, and what you want to control this LED with the help of some web interface which is available at remote place, at some remote desktop place. and you have designed, suppose you have designed this simple web interface with the help of some HTML coding, okay, where you have two different buttons, LED on and LED off. So when you press this button, it should off, it should on, and when you press this button, it should off. And these two, this is at one terminal at some remote place, and this is at another place with some. Okay, so the distance between these two is very long. Okay, so that because we, so in that scenario is that we cannot utilize normal protocols for communication in between them. We have to use IoT. Okay, so for that what we can do, we can use cloud platform. What we can do with the help of this cloud platform, we can send this data from, first of all, from web interface to cloud. Okay, so cloud is acting as a database for us, so we are sending the data from this to cloud, and then from cloud we can receive the data to this device. And for that you can see these are the arrows. There are some API keys which are provided with this by this cloud platform for reading and writing. Suppose you want to write some data, so there is some API key provided by the cloud platform, so you can code it into your HTML coding for sending the information to cloud. Similarly, at the device side also, we have some API key provided by the cloud, read API key, so that we can code this information in it and read the data from the cloud. So this is way, in this way, with the help of API keys, we can able to communicate the web interface with the help of this device. Okay, and definitely all these things are backbone with the internet. This also require internet, this also require internet, and this also require. And it may not be necessary that these all things are at the same place. This may be at one place, this may be at another place, and this may be at another. Suppose this is in UK, this is in Germany, and this is in Nepal. Okay, but you have a complete communication. There is no issue in that, right? So this is one aspect of it that is called as a controlling application. Okay, another application. Now this is just an example uh, for you people to understand the scenario. Now we have the application. This controlling application may be anything. Okay, you can have a much more complex system over here. Okay, and you can build accordingly. Similarly, in this another application is the monitoring application. Suppose you have sensor, one sensor, some temperature and humidity sensor. DHT11 is a very popular humidity and temperature sensor. Okay, which is considered as a digital sensor basically, having 4 pins: ground, not connected, data out, and VCC. VCC and ground, it requires plus 5 volt and ground, and data out, it will provide you the digital output, which we can connect to any of the GPIO pin of this NodeMcU board. You can see over here, and we'll take the information from it, the temperature and humidity information. Okay, now what we want, once we are sensing the data from of the environment, that is temperature and humidity, we want it to send it to the cloud for the monitoring purpose. Okay, so that any person who's sitting at some remote place will sense, okay, what is the temperature of my house, what is the temperature of that particular point, okay, in my house, or humidity over there, so that it can visualize from there. So for that, we have a monitoring application. In that case, your NodeMCU is having some DHT11 interface, and with the help of this DHT11 interface, you are sending the data onto the cloud. That is thing is speed. Okay, with the help of write API key, using the write API key provided by this cloud, and you are visualizing this information onto this cloud into the respective fields which you are created or which you have configured inside this cloud platform itself, like your temp humidity field and this your temperature. So inside that cloud we can configure fields, okay, respective fields for humidity and temperature, and whatever the data you are sending, it would be displayed in the form of a graph over here, and it is a time stamped data. You can see over here, it is a time stamped data, and whatever the data you are sending, it is represented in a time as a time series data, you can see. Okay, for every instant it is displaying the information. Okay, so in this way you can visualize the sensor information into this cloud at a remote place. Your device is at one place, and your information or your cloud is at another place, at some remote place. Even you can integrate these graphs onto your self-designed web pages also. Okay, suppose you want to don't use you want to use this cloud as a backend, so and you want to use these graphs as a front end onto your some web interface, so you can use that in that particular fashion. So this is how basically you can solve the purpose. So in general, there are only two things in IoT ecosystem. One is called monitoring and another is called control. You can have that application in which monitoring and control are there in a single application also. That type of application would be there. Here I have given you the example of two case studies in which we have shown in first case we have shown only controlling part, and in second case we have shown only monitoring part. But you can have that type of applications as well where we have monitoring and control both. Okay, so that's it, my dear friends. Thank you so much for listening me carefully.
Thank you so much, Dr. Gaurav, for this such nice presentation. Now, participant, do you have any kind of question related to any kind of thing? You can raise your question. You can ask your question in the chat section or the question answer section. Any questions? I guess no one is having any question. So,
Yes, sir. Either students, because when we don't have the question, so there are only two scenarios. Either students have understood everything, or they didn't understand anything.
yeah.
It's fine, sir. No issue. My best wishes to the students, and I am available for any sort of help if they want anytime.
Yes, yes. Thank you. Thank you, Dr. Gaurav, for your presentation. Thank you. Thank you
Thank you.
from Lord Buddha Education Foundation.
Thank you.